Today we are talking about tornado shapes. Most people think the deadliest tornado is the biggest one, or the fastest one. But what if I told you that some of the most lethal tornadoes in history looked almost harmless when they first appeared? And that knowing what a tornado's shape means could be the difference between making it to shelter and not making it at all. Today I'm breaking down the deadliest tornado shapes, and for each one, I'll show you exactly what that shape has already done. Needle tornadoes. Imagine you're driving a back road and something catches your eye. A thin line hanging from the clouds, so narrow it barely registers. You slow down, squint, and think, that can't be a tornado. It looks like a scratch on the sky. That moment of hesitation is what makes needle tornadoes deadly. These form when rotation is tightening, but moisture is too scarce to build a visible funnel. What you see is the vortex itself, barely revealed, almost translucent, sometimes no wider than a telephone pole. They appear and vanish in seconds, but the winds are real, exceeding 80 to 90 miles per hour, more than enough to tear roofing and send debris tumbling across a field. In 2016, storm chasers documented a needle tornado near Campo, Colorado. It lasted less than a minute, was barely visible against the sky, and still damaged farm equipment before dissolving like smoke. Size is not a measure of danger. If you're waiting for something dramatic before you take shelter, a needle tornado will have already come and gone. Rope tornadoes. Now picture something beautiful. A ribbon hanging from the cloud base, twisting and swaying in hypnotic motion. Then it touches down and rips a barn apart in under 5 seconds. Rope tornadoes form during the dissipating phase, when the funnel contracts and narrows into something that looks fragile and ready to disappear. Everything about its appearance says, this is almost over. That appearance is wrong. When rotational energy compresses into a narrow column, sometimes only 50 to 100 feet wide, wind speeds actually spike. Conservation of angular momentum. As the radius decreases, rotational velocity increases. The same physics that makes a figure skater spin faster when they pull their arms in. A rope tornado can produce EF2 or EF3 winds in a concentrated zone, even as it looks like it's about to vanish. The Mayfield, Kentucky tornado of December 2021, the one that killed more than 70 people across western Kentucky, spent part of its long overnight track in a rope stage while still maintaining devastating intensity. It snaked and twisted across the landscape in the dark while people slept. Elephant trunk tornadoes. Something is changing now. The funnel is thickening. The bottom is getting heavier, wider, pulling more debris from the ground. The shape that emerges looks exactly like what the name suggests. A massive trunk reaching down from the sky, curving slightly, feeling its way across the landscape. This is a tornado in transition, and that transition is towards something more powerful. Elephant trunk tornadoes form when the vortex intensifies and pulls in increasing amounts of moisture and debris. Where the rope looked fragile, the elephant trunk looks purposeful. They can reach EF2 intensity or higher, and they rarely stay in this shape. The elephant trunk is the warning that something larger is about to announce itself. The Simla, Colorado tornado of June 2015 became one of the most photographed elephant trunk tornadoes ever documented. It swept and curved across the open plains, causing significant structural damage before strengthening further. Cone tornadoes. If you were asked to draw a tornado, you would draw this. Wide at the cloud base, tapering to a narrow point at the ground. The classic shape. The one on every warning sign, every weather graphic, every childhood drawing of a storm. Here's what most people don't realize. If you're looking at a cone, you're not watching a tornado begin. You're watching one that is already committed to strength. Cone tornadoes form when rotation has fully organized, and the mesocyclone above feeds the vortex with sustained energy. Many EF3 and EF4 tornadoes spend most of their lives as cones before growing into something wider. The Tuscaloosa, Birmingham tornado of April the 27th, 2011 spent much of its deadly 80-mile path as a massive cone. Witnesses described a perfect dark triangle cutting through neighborhoods. It reached EF4 intensity and killed 64 people. The deadliest single tornado in Alabama history. Stovepipe tornadoes. The funnel is no longer tapered. Perfectly vertical, uniformly wide from the cloud base all the way to the ground. No narrowing. Just a solid, dark column. Storm chasers go quiet when they see a stovepipe. These form when the vortex pulls in enough moisture and debris to fill the condensation funnel completely, top to bottom at a consistent diameter. Organized, sustained rotation throughout the entire vertical structure. No weak sections, no thin points. But here's the hidden danger. Stovepipes look comprehensible, like something you can judge, estimate the distance, decide how much time you have. That clarity is false. A stovepipe 1 mile wide and one 300 yards wide can look almost identical from a distance. The Greensburg, Kansas tornado of May 4, 2007 maintained that shape for miles across the open prairie. It reached EF5 intensity and killed at least 11 people, destroying 95% of the town, striking after dark, nearly 2 miles wide, while residents thought they still had time. Barrel tornadoes. A barrel tornado is huge, round, and impossibly thick. But here's what makes them unnerving. They don't just look bigger, they are bigger. Larger than stovepipes, with bulging sides that look like rotating water towers tearing across the ground. Barrels form when the tornado wraps itself in multiple layers of condensation and debris, creating a heavy funnel with enormous mass. Their wind fields stretch far beyond what's visible, and the debris cloud beneath them grows so deep it hides the true width of the vortex. What you're looking at is never the whole storm. The Joplin, Missouri tornado of May 22, 2011 took on a barrel shape as it intensified to EF5 strength. It killed 161 people, the deadliest single tornado in the United States since modern record-keeping began in 1950. Entire neighborhoods were erased. The debris cloud was so thick and wide that many people didn't understand what was coming until it was directly on top of them. Wedge tornadoes. Stop thinking about tornadoes as funnels. What you're looking at now isn't a funnel at all. It's a wall. A massive, churning wall of cloud connected directly to the ground, wider than it is tall, stretching across the landscape for over a mile. Wedge tornadoes create a deadly illusion of slow movement. Because they're so enormous, your brain concludes they're barely moving. They're not. They travel at the same forward speed as any other tornado, typically 30 to 50 miles per hour. You can't see the edges. When a wedge hits a town, it doesn't pass through. It engulfs it. The El Reno, Oklahoma tornado of May 31, 2013 reached a record-breaking width of 2.6 miles, wider than Manhattan is long. 3 veteran storm researchers, Tim Samaras, his son Paul, and colleague Carl Young, were killed along with an amateur chaser and 4 others. 8 people dead in total. Even professionals couldn't judge their position relative to its edges. When a tornado is that wide, distance means nothing. The Bridge Creek Moore tornado of May 3, 1999 showed us just how violent a wedge can get. It produced the highest wind speed ever recorded in a tornado, 321 miles per hour, measured by mobile Doppler radar. It killed 36 people and left thousands of homes in ruins across southern Oklahoma City and more. Which shape shocked you most? Drop your answer in the comments. And if you want more tornado content, hit subscribe.